To start the assembling, put down your GPR like shown, the rear and front antenna, the telescopic arms, and in the middle the main unit. The next step is to gently press the telescopic arms into the openings, and like you can see, there is a silver button that is facing upwards and needs to be clicked. Now we connect the both antenna connectors to the main unit by just slip it over the two pins and turn it around. Now we slide the opening from the telescopic arms into the quick release and tighten them up. We do this on both arms and secure them. As shown, the main unit isn't high enough to grab by hand, so we need to adjust the height of the machine by just turning the clamp holders, adjust the lengths, and secure them again so they can fall out or slip out. Now we replicate the steps on the other side, adjust the lengths equally. As you can see now, the main unit is way higher than before and we barely can touch the handlebar of the main unit. Now we double check by lifting up the radar and it seems to be perfect. Now we can start to turn the cables around the shaft and connect the main unit with the antennas. We repeat the steps from before on the rear antenna. We line up the cable, plug in the connector and secure him. Now just put in your laptop into the middle holder, the magnets will snap in and you are set to go. To disassemble the GPR, we just need to disconnect all our connectors, reverse side like before. Next step is to open the quick release, slide out the telescopic antenna arms on both sides. To separate the telescopic arms from the main unit, you need to know that you need to press this little silver button to loosen the connector and then you can pull it out. Now just open the clamps from the telescopic arms, put it to its original length, secure it again so they won't fall out and stay fit and tight. If you want to recharge your antenna arms, you just need the AC connectors, the arrow needs to be up, near the silver button, you press it in and they stay secured. Repeat this on the other side, arrow up, silver button up, click in, and wait till the lights go on, so now it's charging. Simply wait till the lights goes off. Then you know your battery is fully charged and you can use your OKM GPR again on the field. To start your GPR measurement, you open the OKM GPR app on the tablet and start your GPR with the power button. If the light now is constantly on, the connection to the tablet is established. You now open a new scan and see that the antennas and the radar are already connected. Via the upper right arrow you continue and activate the integrated GPS. On the main unit you see that the green light turns blue, which means that you have a solid GPS signal. Confirm with the right button and gives the scan a unique name to identify it later. Now the scan method is chosen. In this case the 3D scan. Then the scan mode. Now choose between Zig-Zag or parallel mode, and then determine the penetration depth. Here low profile, start measuring in the lower right corner. In the parallel mode you set the first line and start the next track parallel to each other. When you imagine your scan field, start the first lane by pressing the trigger button on the main unit. Now, start to walk your lane slowly. To achieve a good result, the radar antenna should be held about 5 to 10 centimeters above the ground. During the measurement, you can see live which data the GPR is collecting and how many impulses are set. When you have reached the end of the measuring field, you briefly press the trigger button on the GPR and walk back to the starting point without scanning. Now you take one step from the starting point to the left, press the trigger button again and start to walk the track at the same speed as before. On the split screen, you can see the distance still to be walked until the end of the track. Since you have set the distance in the first lane by number of impulses and your own walking speed, the radar will automatically give a final signal when you reach the end of the line. Then you start the third line, just like the two previous lanes. Same distance to the ground, same step length, and same distance between the lanes. You can walk any number of tracks. Your GPR will stop you each time. You can use the impulses of the device to acquire a pace, so that you always walk at the same speed and get a consistent result. The fourth scan line is finished by clicking on the small X. Save the scan by clicking on the check mark. When you perform your scan with activated GPS, you can simply take over these data for longitude and latitude and confirm them now. Now the 3D graphic is created completely automatically and shows you clearly what is in your scan field. The whole graphic can be turned, the measuring depth of anomalies can be determined and visualized in different color scales. We will explain this in the next tutorial. Today we take a look at one of our measurements that we performed with the Gepard GPR. Since we saved our last measurement, we can analyze these quite easily at home in detail. First, we start the Gepard GPR 3D app on the tablet. Then we choose View Scan and select our saved scan, in our case, Test YouTube. Here we already see the image, but we check again if we have chosen the right properties for the scan. We click on this icon. Here we see a wide range of different soil types and we choose the one that best suits our case. For us, it was clay-wet soil. The better we determine our soil type, the better and more precise is the determination of the depth. By clicking on this icon, we make sure that we have entered our measuring field size correctly. With this button, we can increase the contrast and saturation and thus get some more information of the picture. We can rotate our image freely and have 3 coordinate axes for orientation. The red axis is our running direction, starting point bottom right to the top. Along the green axis, our individual measuring lanes are created, starting at the bottom right and moving to the left. The blue axis indicates the depth. These 4 quick views allow us to view our image particularly fast in different perspectives. Side view, scan direction in the ground, from above in scan direction, side view parallel to the scan direction. To find out how deep your object is located, we click on the crosshairs. Now, 3 new axes appear, which can be moved onto our object. To do this, we click on the corresponding coordinate axis, keep it pressed, and move it to the desired position. Again, we can use the quick views. Now, we can look into the gray status bar at the bottom of the screen to see where our object is exactly located. We can see in which measurement lane it's located at how many impulses the objects become visible, and in which depth the object is approximately located. Remember, the more exactly we have selected our soil type, the more exact is the determination of the depth. We also can view our scan in the 3D view in a different color scale and in a cross-section. In this view we can also move our markings, the crosshairs, from the 3D view to a new position. In the 3D view we can also access the raw data, which offers further interesting information. More details will be provided in an additional tutorial. Back in the 3D view, we can export our visual representation into various formats.